Welcome to CS1033 Programming Fundamentals, the lecture series on problem solving. And we are going to discuss how specialized data structures can help us create programs that help us develop solutions. First, we'll look at the widely used data structure called list. So I will start off with the introduction to the list data structure and then look at how to create lists and a wide variety of operations that you can carry out on lists. So when we look at data types, we basically have three categories. The primitive data type, which is what is directly solved by computer programming language. And then we have the composite type. This is what we normally call as a structure. And there are two types. One is the built-in structured collections of primitive types. If you take, for example, the array is a good example of this. And other composite types that the programming language already provides for us. Okay, so that we don't have to create by ourselves. So these two types, the primitive types and composite types, are part of the programming language. So when you learn, for example, Python, you learn about these primitive types and composite types and the operations that are possible with them. And the third type is the abstract data type. These are essentially data types that we create as engineers and programmers. The idea is that we would model the behavior of a data type in terms of how we see they operate. Okay, so as we proceed through this lecture, you will have a better understanding about these abstract data types. And just for clarity, the primitive data types include the Boolean, which has the values of true and false, and the characters, which are from a alphabet, an encoding scheme like ASCII that we have available from our computer language, computer programming language, and integer numbers which have fixed precision, and floating point values, which are the real number, which represent real numbers. And so these are actually quite familiar to us in everyday usage also. Okay, the numbers and characters and the Boolean values. In addition to that, specific to computer programming, we have another data type that allows us to refer to memory location. In certain program language like C and its variants, we call them as pointers. Okay. And another type is the enumerated data type. So many programming languages have a mechanism where we can define a data type by enumerating all possible values. Okay, so let me repeat again the important aspects of primitive data types. One is we know all the values or all the possible values. For example, in Boolean, all the possible values are true and false. There are only two values, true and false, Boolean. Characters, so depending on the alphabet that we are using, we will have the encoded characters. So if you take what you see on your keyboard, you have A to Z, the capital, A to Z, the simple, then 1 to 3 to 9 and 0, the numerals, and then the special characters. So all of them together. So they are actually characters that we can see. And in a computer character alphabet, there are some characters which you cannot see. For example, the enter key that you have, actually you cannot see it directly, and they would be also part of the encoded character set. And floating point numbers, of course, that is not enumerable. So that's the nature of real numbers. You cannot enumerate all the numbers, but we can specify the numbers as a range. For example, if you take real numbers between 1.0 and 2.0, we don't know how many numbers are there. It's not countable, but we have a good idea what are these numbers. So every number would be 1 point something, and that's one end of the range, and the other end would be less than 2.0. So 1.9999, like that. So the idea is we know all the values. Similarly, if we are able, I'm sorry, yeah, when you take memory location, similar to that. So we the memory of the computers we use are finite. So they have maybe 8 GB of memory. So every location would have an address, and the enumerated values. If we are able to enumerate values, then we can create data type. For example, we can create data type called days of the week and label it as Sunday, Monday, Tuesday, like that, the 7 days. So similar to the months of a year, January to December. But we will have to enumerate every value. And apart from the values, we should also specify the operations that you can do. Okay, for example, with Boolean values, you have logical operations of and, or, not, like that. And the operation should make a meaningful outcome. It should result in a meaningful outcome. So if you take integers, you have the addition, subtraction, multiplication, division. Division can be either integer division or the modulo, whatever the remainder after division. Whereas real numbers, you have the addition, subtraction, multiplication, and real division. And you can do negation of numbers also. But if you take characters, it would not make any sense to talk about subtraction of characters. And if you take addition of characters, we have to define what we mean by that. Maybe that is about concatenating the characters into a string. So, so the important aspects are all the values that are permitted in a primitive data type and the operations that are allowed. Composite types, the most widely used ones are the array that we use all the time. So an array is a sequence of values that we have, where we can refer to them through an index value. And the record data type, which puts together types of different values. So one important thing about array is, in an array, all the elements in an array are of the same data type. In a record, that is also another collection of values, but they could be of different types. So your address, postal address, could be a record. It has a number, which is the house number, and then some character arrays, which give the lane and the town, and another number which could be the postal code, Uh, the another name for the record is tuple. Okay. Similarly, when you take an array, the if the array is a array of characters, we have a special name called string. And third type is union. The abstract data types, as I said earlier, are data structures which we model based on their behavior. So a list of items we can represent as a data type. Okay, so we'll be looking into the details of that now. Similar to that, we have many other data types which we categorize as abstract data types, list, set, stack, queue, like that. And all of them are defined by the operations we perform on them. Okay, so let's start our discussion on the abstract data types by looking at the list. So the definition is quite straightforward. A list has a countable number of values, and the values that you have in a list are not unique. So the same value can occur more than once. These values in the list are in an ordered collection. So we can ask the question, okay, what's the first value in the list? What's the last value in the list? And we can do that only because it is ordered. If there is no order, we can't talk about what's the first one and what's the last one, like that. So essentially, every item in the list has a location or a position within that collection. So if that is the case, we can refer to these values by an index or the address. So this is a very useful capability because with the availability of an address, we can iterate through a collection. Iterate means we can go through the collection by referring to the item's position. Okay, so so we don't have to know what the value is. We only need to know its location. So so we can by referring to the location get all the values that are in the collection. So the so as in every abstract data type, list also has this set of what we call typical functionalities. Okay, so obviously, no, we will have to create a list. So there must be a function or a method to create such a list. And when you create a list initially, that would be an empty list. Okay, and but after you work for a while with the list, there will be values in the list. So we would have the requirement to see if a list is still empty or not. Okay, and we need the capability to add items to the list. So that we can do by adding to the head of the list, which we call prepend, or adding to the tail of the list, that means the end of the list, which we call appending. Also, that is about adding items to the list. We have the need to now access these values in list. So we can access the list items by referring to the head of the list. So whatever is the item at the head of the list, that the first item, that's a special way of accessing. Apart from that, as I said, because this is a enumerable collection, and enumerable means so it has this finite set of components, elements, as well as iterable because each one has an address. We can give that address or the index and get whatever the item. So if you want to read the value, we can use a method to get the value. And if you want to write the value or set the value, we can use a similar method of set. And similar to the first item that we get as head, all the items except the head we can get by referring to as the tail. Okay, so mind you, tail is not the last item. Head is the last item. Tail is the set of items except the first item or the head. Okay, so if you are given a head and a tail, then you have the full list, the full collection. So now I'm sure you can recall from your programming part of the course that when we create arrays, they are static. So when you define the array, the size gets fixed. In Python, the list is similarly an array, but it is dynamic. So here is an array that can grow as we add items or shrink as we remove items. Okay. So and that happens at runtime after we create it. Also, as we have discussed, the arrays all contain values of the same type. Okay, so we call it homogeneous. Okay, whereas a list, it is not necessary for that to be homogeneous. It can be heterogeneous. It can contain values of different types. Okay. And if you take the list, the individual values in the list can be changed whenever you want to store new values. Okay, so therefore we call a list as mutable also. The addressing we talked about for the list. So the first item has the address or the index value 0 and increasing from that towards the tail, toward the end of the list. Okay. When we want to create a list in Python, we can simply do that by enumerating the values that should go into the list. That means writing down all the values, separate by a comma, and putting that within square brackets as indicated here on the slide. So I have highlighted the important properties of a list. Okay, it's a dynamic array, so it can grow and shrink at runtime. Values need not be homogeneous. They could be heterogeneous. That means the values contained within it can be of different types. But very often we find in list values of the same type. Okay, so in practice you see that very often, and the values are mutable. They are ordered and indexed. So these are key properties of list. I have some sample code showing here the creation of lists using Python. Here on line number 1, you can see an empty list has been created. Okay, and on line number 4, we have a list of integer values. Okay, and line number 7, a list of strings. Okay, these are strings. So each value is a character array. So as I mentioned briefly, character arrays have the special name string. And you can see here, so all these, okay, blank list doesn't have anything. The next two lists of integers and strings are homogeneous. The list that appeared in line number 10 that you can see is heterogeneous. First item is a character. Second item is a string. Third item is an integer value. So on and so forth. Okay. And not only that, a list can contain as its elements other lists also. So that I have shown here in line number 13. The first element, that is at element at index number 0, is a list by itself. Okay. And it is a heterogeneous list of string, character, and an integer value. And this list by itself is again heterogeneous because the first item is a list, the next two items are strings. I have shown here a screenshot when you execute the sample code. So Python is a programming language that is widely used for processing of data to prepare them for various tasks. For example, I'm sure you have heard of the area of machine learning, where we get a computer program trained to look at data and then make decisions. For example, the data we get the computer program to look. Okay, so I'm using the term look to give you a sense of what is really happening. So we can get a computer program to look at photos. Okay, and by showing these photos, we train it to identify, for example, animals, cats. Okay, so among a lot of photos, using a lot of photos where we have all kind of animals in those photos, we can train it to identify cats. And so that is images. Okay. Also, we can give it a lot of text data and get it to identify certain terms. Okay. So you read, you give it text, and we get the text to, we get the program to identify positive statements in the text. This kind of applications are very important. For example, if you use a system to collect user feedback. Okay, so we have the model system. So you are using that for your learning purposes, and we ask you to fill in online form to express your ideas about the system. So obviously you will have some negative opinions as well as positive opinions. So rather than a human going through all these feedback and trying to figure out what are the good things and what are the bad things, if we can get a computer program itself to do that and build a summary, that would be great. I'm sure you would agree with that. So for that purpose, now we will have to get all this text that is input to the system prepared. Okay, we have to pre-process them. So Python is a language that is used for that kind of work very often. Okay, so along those lines, Python provides a significant set of interesting functionality. One of these is the slicing of a list. Okay, so if you have a list and if you want to break it apart into sub parts, Python has a very convenient way of doing that using the colon symbol. So let's look at how you can do that. Now, if we want to slice or cut a list from the beginning, okay, that means 0 to a range defined by a value. Let's call that value as index. So this is how we would specify that. Square brackets. So we don't write 0 here. It is implicit that it is 0, colon, and the item to item until the index to which we want to cut the list. So that is starting from the 0th element, from the front. If you want to do the same thing starting from the end, we can specify it in this manner by giving a negative index. And if you want to start from the given index value and splice or cut the list until the last item, then we use this notation. So we don't specify the last item. So if you have n items in the list, the addresses would be 0 for the first one, 1, 2, 3, and n-1 would be the last address. We don't write n-1 here, just as we didn't write 0 here. So that is implicit. So we say from index to colon, and this is how we specify. So that is either going from the beginning to an index value or going from an index value to the end last item. In addition to that, we can specify the start and end and get a sub list from the given list. And we can refer to the full list using this splicing operation. In that case, this is the notation. So now this should be quite obvious to you, because now starting index we are not specifying, that means it is implicit, okay, 0. Ending index we are not specifying, it is implicit, so it should be n-1. So essentially what we are saying here is this is the full list. Now the usefulness of that type of reference into a list is, if we want to reverse a list, we have a very quick way of doing that. So here we are specifying the reversal of a list. The full list being referred and asking us to give the list starting from the last element. Okay, so this is how we specify the reversal of a list. So these operations, I have a sample code for each type, and when you execute, this would be the outcome. So if you have a list given in this manner, 0 to 9, you should look at how the sublists are given. So I am asking for the until the from the beginning. So this is the beginning until the fifth element. So 0, 1, 2, 3, 4. So that's fourth one is the fifth element. Okay, and I can ask for the splicing of the list starting from the end. So you can see, so I'm referring negatively, so -1, and then I'm asking up to the 7th position. Okay. Um, and yeah, so here I have, for example, starting from the 5th element, going until the end. Okay. So yeah, you should try these commands to see how they operate, and if you refer in this manner, you get the original list. As you can see here, you get the original list, and this is the list reversal, which is what we have here. Okay. Now the next operation I want to discuss is how we would refer to a list as a variable in a program. Okay. And how the variable behaves when we use it in a program. Okay, so there are two things I want to discuss. One is when we refer to a variable, the use of the original variable in our programs, and how to refer to a variable so we get a new copy. Okay, so let me explain that with this sample code. So we have a list, okay, that we create using the Python instruction of square bracket to indicate that we are going to create a list, and the values in the list enumerated and separated by commas. Now, if I create another variable, okay, another variable, ref L, and assign L to that, what happens here is I don't get a new list created. It is only reference to the existing list. Okay. So I will show this to you, the creation of the creation of a variable that refers to the same data structure by using this method or the function called ID that is available to us in Python, which tells the memory location of a variable. Okay, so this function ID, when we pass a variable as the argument, will tell us what is the memory location of that variable in our computer's memory. Okay. So first of all, I will assign the variable L to this new variable ref L. That's one type of assignment. The other type is I will use the splicing operation. Okay, I will use the splicing operation and assign to another variable. This one I am calling new L. Okay, so you can see here my splicing operation actually refer to the entire list. Okay, so in a sense, there is no difference between L and L with the splicing operation, because in both cases you get the full list. Okay, this will give you the full list. So let's run this code and see what happens. So you can see the memory location of the variable L is given here. Okay, so let's only look at the last 5 digit, 40256. Okay, that's the memory location. And when I create a new variable ref L and reference the same variable, you can see the ID of that variable is also the same memory location. Okay, so now I have two variables pointing to the same memory location. But when I use the splicing operation, you can see I have the same list, but the memory location is now different. It's 08160. So a copy of the array has been created at a new location in the memory. Okay, so so this is the difference between referencing and copying. Okay, so if you want to make a copy of a list, there's a straightforward way of doing it using the splicing operation. Now let's look at a few of these methods that are available for us. So the method len returns the count of items in the list. Okay, so so you simply call the method and pass the list as an argument. Okay, so I have the example code here. So the empty, this is the empty list or the blank list, and the length would be 0, and thereafter so if you have this list which have integers, so there are 4 elements, and you can see this one is a list that contain another list as its first element. Okay, but the count, the length of the list will be 3 because the first element, which is a composite element, a list itself, is counted as 1, as one element. And let's look at how we could iterate or loop over a list. That means to go about accessing elements one by one. As we said, a list is iterable correction. So there are several methods on how to access these items one by one. Okay, one of the method is to directly use a for loop. Okay, directly use a for loop. You are familiar with the for loop, and we will use a loop control variable to get the elements. So so here's our list L, and this is our loop control variable. Okay, loop control variable. So now whenever we refer to the loop control variable within the loop, every time we go through a loop, we get the next item. Okay, next item. So we start here from the beginning. So first time we come into the loop, we get the first item or the item at the 0th element, 0th address, and then the next time around we come to the loop, we get the item at the address 1, like so on and so forth. Okay, so this straightforward using a for loop. We can use the function called enumerate. So this function is available in Python, where we pass as an argument any enumerable collection. Okay, any enumerable collection. So a collection that through which we can iterate is enumerable. So now here we have the loop control variable, that is the index. Okay, it is the loop control variable, and then the enumeration function here will return items to us through the enumeration variable, the item variable. Okay, so so that's the second method. We can also use the range function. Okay, so in Python 3 and onwards, we have the range function. Earlier we had xrange also, which we have discussed in the previous lecture. Now here, when we give the range, we have to specify a numeric value that we obtain from the length. Okay, so after that we treat the list simply as a iterable list where we refer to the elements by its address. Okay, so this is essentially the splicing operation. Okay, splicing operation with only a single element. Okay, so whenever you refer to the elements, you get the element at the particular address. So here we have the sample code showing how the scheme works. Okay, so 3 different ways of looping over a list. Let's discuss the property of mutability of a list. So if you take a list as a data structure, is mutable. Okay, so we can change its content without changing its storage in memory, right? So if you have a list of say 10 items like here, so when you create it, memory is allocated. So here you will require memory to store 10 integers, and the system will allocate that memory, and after allocating that memory, in each memory location, this value will be stored. So remember, in the first memory location, the value 0, and the last memory location, the value 9. So the Python interpreter will complete this task of allocating memory and storing these values. Thereafter, we can assign values to the storage locations in the memory, and they will get changed. So we can see that whenever we change the content gets changed, but the memory allocated would be the same memory. So it is not like you are changing the list by changing its values and creating it in a different location in the memory. Okay, so as earlier, we can use the id function, which returns the memory location to see its behavior. Okay, so let's look at the example code. So you can see I have created a list. Okay, I have created a list in line number 1, and then in line number 2, I am printing the list. So that is what you have here, and I'm checking its address. So just only look at the last 5 digits, 06528, and thereafter I'm changing the content. Okay, I'm changing the content. So the at address number 1, where I earlier had the integer value 1, I am changing that into a character. Okay, B. So you can see I have changed that, and the address remains the same. Okay, address remains the same. So while the contents got changed, the memory address of the variable did not get changed. Okay, now okay, so so if you take an integer, okay, so to store an integer, if it is a 32-bit integer, you will require 4 bytes. Okay, 4 bytes. So if you consider this particular structure in memory, it will require 40 bytes. Okay, 10 integers, each integer 4 bytes, that means 32 bits. it will require 40 bytes. Okay. Now, if you take the second list, now that should change, because now we have 9 integers. Okay, 9 integers and 1 character. A character would require only a single byte. Okay, single byte. Or depending on the character encoding, maybe 2 bytes. Okay, but definitely not 4 bytes. So of course, when I'm printing, because I'm using these quotations, the list is shown as a longer one, but in memory, actually this should now shrink, because you need less space for this particular value. Okay. But no, the way, so now probably you can get an idea how things get stored in memory. So if you simply store only the value, that would be a problem, because how do you then differentiate about between an integer and a character value? Okay, so the Python system, when it creates a list, because it allows for these heterogeneous data elements, not only it should store the value, it should also store other, what we call metadata. That means data on data. That is what we call metadata. So whether this is an integer or some other type. So here it would be of type integer. Here it would be of type character, like that. Okay. So in actual fact, the amount of memory required is not the number of elements multiplied by the memory required for a single element, because that will not work if you have different data types. So so these are important things to learn as an engineer. Okay. Okay, so so as you can see, I have changed the value here. The address did not change, and here now I am even removing one item. Okay, so this is basically a splicing operation, because I'm working with a single element and removing it, and you can see now the list has got one less item. So if you look at the length, originally the length is 10 items. Now this will only give 9 items if you check the length, but the address remains the same. Okay, so this is what we mean by mutability. We can keep on changing the contents of a list, both the stored value as well as the type of the value as well as the number of elements, and still the list will be in the same location in the memory. So if you have used other variables to refer to this particular variable, so I have the variable L here. So if I have, like what I have shown earlier, used different variables to refer to the same variable, say I have L1 is a new variable which to which I assign the variable L, L2 to which I assign like that. All these variables would still be referring to the same same original memory location. So all three L1, L1 and L2, all three variables will be referring to the same same list. Okay, so this is quite useful for many applications. So in that example, we looked at how we can remove an element in the list by using the del operator. We'll discuss that in a little bit more detail. But let's see how we can add elements to the list. So for that, we have the append method. So the append would add elements to a list at the end of the list. Let me show you the code. So sometimes the code is too the image is too small. So let me explain from the text here. So this is the original list, so a blank list. So when I append a value to that list, that would become the first value, okay? And when I append again, that becomes the second value, and so on and so forth. So values would keep getting appended as the last item, okay? So the so this is the outcome, okay? A list with 3 elements. Now I can use the iterator for adding also. I will in this case use a loop control variable I and use the range function and specify the range as 1 to 4, and now I will append, okay, to the list. What I'm going to append are the integer values. As the list is a heterogeneous data structure, we can have strings and integers and any other type. So now you can see after appending, I have the values 1, 2, 3 at the end of the original list. Okay. So as you know, when you give the range function, it starts from the first value and goes until the last value except that value. Okay, so the range here would be 1, 2, 3, and when it is 4, it will stop the iteration. And finally, I have another list which I have created. This again a heterogeneous list. First item is string, second item is an integer value, and I'm going to append that list to the original list. Okay, so you can append a list to a list. So now this is very important. Okay, so when you append a list to a list, the new list that you are appending will go into the original list as an element. Okay, so it is not like a concatenation of list. The new item, the new list will simply go as a single item to the list. Okay, so so this is very important concept again to remember. If you have a list, say 1, 2, 3, and if you have another list 4, 5, 6, when you append, you don't get a list like 1, 2, 3, 4, 5, 6. Okay, you don't get that. What you get is 1, 2, 3, and then as a list, one single element 4, 5, 6. Okay, so so this, you don't get this. What you get is this one. Okay, so very important, remember. Okay, so it is not a concatenation of list when you use the append operation. We just add an element as a new element. Of course, now it would be interesting to discuss how we do that concatenation. That is quite straightforward. What you need to do is iterate through the second list and keep on adding to the first list as a single element at a time. So you can do that using a for loop, for example, and accomplish the concatenation of two lists. Okay. Right. So let's look at another method. So these are all built-in methods available in the Python language. We have looked at how we could add elements to the list at the end by using the insert function. We can add at specific locations. So obviously it takes two arguments. Whatever we want to insert, that is the value, and the position at which we want to insert. Okay. So here we have the value, that is what you want to insert, and this is the position at which you want to insert. You should carefully look at the exact position where insertion happens. Okay, so let me show you that through the running example. So I have a original list called University Moratuwa. So this is a list of two strings at location 0 and 1. And now I am going to insert a new string called off at location 1. Okay, location 1. Let's see what happens after that. So yeah, so this is address 0, this is address 1. That is where it got inserted, and you can see the previous item got shifted forward. And thereafter, I have these insertions of inserting at 0, 1, and 1, like that. Okay, so let's look at what happens. So if when I say insert 0, it gets inserted at the 0th address, at the 0th element. So that becomes the first value in the list. And then I keep on adding other terms, for example, CSC. So I don't have the intermediate ones printed. After adding department, it would be Department University of Moratuwa. After adding CSC, that would be department. Well, I'm adding at address location 1, it would be Department CSC University of Moratuwa. And then finally, when I add off at address location 1, this would be the final list. Okay, so it's very important for you to have a sense of where exactly the insertion happens. Now, the append method allowed you to append one item. Okay, we have another method called extend, which allows us to add multiple items to the end of the list. Okay, so the method would be called in this manner. Okay, so extend is a method that we call on a list, and we pass as the argument an iterable collection. Okay, an iterable collection. So list is an iterable collection, and you can see what happens here. Okay, so this one I just showed you earlier when I said, you know, if you have a list called 1, 2, 3 and another list called 4, 5, 6, what happens when you add? Okay, so so here's the original list 1, 2, 3, 4, 5, and then you have the second list 6, 7, 8, 9, 10, and when you do the extend, the items in the second list are enumerated and added one by one. Okay, so if you just did the append, this second list 6, 7, 8, 9, 10 would get appended as one single element to the end of the original list. Okay, but because we are doing extend, we are using extend to at the second list. What happens is that list get iterated 6, 7, 8, 9, 10. The single individual elements get iterated and added to the original list. Okay, so either you can do this yourself by using a loop structure and appending item by item to the original list, or you can simply use the extend function. So you may want to ask, what's the difference? Okay, the difference is, one difference is obviously you will write less code. Okay, less code. So rather than having to write your own loop structure and extending an existing list, you will simply use a single method code. Okay, so your code is shorter and your code is more readable, and also it's more maintainable. So these are all these good features that we discussed in the first part of the first lecture. Second thing is, because now this is implemented by the Python system itself, it will be an optimized version. So it is again a loop construct. So the Python system also has to go through the list you have given and take one by one items and add them. But because it is done by the runtime system itself, the code will be optimized and will be faster. So there are a lot of advantages to using library functions themselves. So we have discussed adding items, okay, either by appending or inserting or extending. So 3 different types. Okay, append to the end, insert to any position you want, and extend, again add, but no, item by item, longer list. So we can also remove items one at a time. Okay, so let's see how that happens. Okay, so when you take a list, for example, I have this example here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In that, I asked to remove item 3. So I have to give the value. Then the Python system will go to the list starting from the beginning, and the first time it has a match, it will remove it. Okay. Similarly, 10, it will go to the list, and when it encounters a match, it will remove it. Okay. However, it is quite possible that you are asking to remove a value which is not in the list, say 20. Then that should generate an error. Okay, so it will give an error. And what happens if you want to remove items not in the full list, okay, but only part of the list? That you can do using an iterator. So so you would specify, so you can use a for loop with a control variable. I is the control variable here, and you specify the range. Okay, so address locations 4, 5, 6, 7. So there are 4 locations up to 8. So when the loop controller comes to 8, it will exit. And you can specifically remove those items. Okay, so I have the example code here showing how that would happen. So original list is 1 to 10, and I'm removing 3. So after removing 3, I have 1, 2, now 3 is not there, 4, 5, like that. And of course, I have removed 10 also. So 10 is also not there. So 3 and 10 are removed when I'm printing here. Okay. After that, I just want to show you the iterated removal. So now I am removing items 4, 5, 6, and 7. So I have removed 4, 5, 6, and 7. So now only 1, 2, and 8, 9 are remaining. Now I am asking to remove 5. Okay, there is no 5, so it will give a runtime error. Okay, so it actually tells what the error is. Okay, so you are trying to remove a value in a list where it does not exist in the list. Right. So we have another way of removal called pop. Okay. Let's see how that works. So this is in pop, we specify a position. Okay. So remember, in remove, we gave a value. Okay. So in remove method, we gave a value saying remove this value. In pop method, we say remove from this position. Okay, remove this position. So this way, we can remove from the first position, last position, or any position by just specifying the position in the list. Okay, now there was an issue in the earlier method when we are removing by giving the value. If the value is not there, it gives an error. What would happen if we try to remove from a position which is not in the list? Okay. So let's look at that. Okay. Okay. So that's one issue, and other issue is what if we don't specify a location? Okay. So let's look at the example here, running example. So we have an original list. Okay, 1, 2, 3, 4, 5. And now I'm going to pop. Okay, without specifying the location. Okay, if I say pop without specifying location, last item will get popped. Okay, so the fifth one get removed. And if I give a position 3, for example, here, now the position will get counted, address 0, address 1, address 2, address 3, and okay, it's the last one, but it is getting popped not because it's last one, because it is address location 3. It is address 3. Okay. Then so now I keep popping. Okay, I keep popping, and okay. So after I pop 3 times, obviously I should get a empty list. Okay, that's it. So I as you can see, I get an empty list. Now I am going to pop again. So this is basically trying to pop an element where there is no element. Okay, so you could have done it here also by saying pop 10. Okay, so it would be the same, saying pop 10 here is trying to pop where there is no element, and here empty list I'm going to pop. So here it says the error is an index error where I'm trying to pop from an empty list. Okay, so you should actually run code, say for example put 10 here and see what the error is. It would still be an index error, but you are not going to pop from an empty list. Okay, check what is the error you get. Okay. Now we have seen how we could remove items one by one. Okay. We can also remove a set of items. Okay. Now for that we have this delete method, which will allow us to delete a set of elements given as a range, okay, starting from A to B. So that is what we have shown here. Okay. Let me discuss the sample code with you. So I have an original list with items going from 1 to 10. Then I am going to delete a sub list starting from position 3 to 7. Okay, let's see actually what gets deleted. Here's the running example. So I have the original list of 1 to 10, and now I am saying delete from address 3 to 7. Okay, so you know address 3 is this 0, address 0 starting 1, address 1, 2. So address 3 would be the item 4. Okay, and 4, 5. So the addresses go from 3. So this is the address location 3, 4, 5, 6. Okay. So because we are saying 3 to 7, what would get deleted is 3, 4, 5, and 6. So 4 items will get deleted up to 7. So address location 7. So that's what you can see. 4, 5, 6, and 7 got deleted. Okay. So I am intentionally giving these values and addresses which are a bit confusing, because you should run this code and see. Okay. So 7 is getting deleted, not because it is item 7, because it is at address location 6. Okay. So what you are deleting is from address location 3 to address location 6. 3, 4, 5, 6. 4 elements. Okay. Yeah. And yeah. So check how these deletions occur. So what happens if you try to delete in this manner? So from address location 3 to address location 7 again. Okay. So address location 3 would be here. Okay. So that's okay. The fourth element. Okay. That's the address location 3. And then you have to delete 4 items. Okay. 3, 4, 5, 6. Okay. 3, 4, 5, 6. There is no 6. So as you can see, it deleted whatever it can delete, but did not give you an error when it encountered a missing element. Okay. So that is also very important behavior to notice. Okay. Let's look at another built-in function, sort. So this method rearrange the contents of the list in a particular order. Okay. So actually you can specify the order. By default, the order is the increasing order. Okay. So I have given here a list where the items are in a random order. Then I call the method sort, and we can see the execution after running. It will be sorted in order. So this is because these are numbers, it would be obviously in the numerical order. And if you have strings, they would be in alphabetical order. Okay. And if you want to sort in the reverse order, not in the increasing order, so or the ascending order, but if you want to do it in the descending order, okay, you can pass this particular argument saying the reverse is true. Okay, by default reverse is false, so you don't have to specify that. Here's what you have with the sorting. So the numbered list get sorted nicely according to increasing order, and this one also now is in alphabetical order, C, E, S, and you can see this A, because it's simple A, is coming at the end. As you know, in the ASCII ordering, capital letters come first. So capital A to capital Z come first, and then simple A to simple Z comes next. So in that particular alphabetical order, simple A is a higher value. Okay. Right. So if you have, I don't have the situation of like same first character. If you have same first character, as you already know, sorting will move on to the second character, so on and so forth. Right. So the reverse method will is another built-in function that will reverse in the reverse order. So so you what you are doing here is doing the sort with reverse set to true. Okay. So so if you look at the reverse method, it is essentially this method. Okay. Sorting in the reverse order. And yeah, so you can check this by reversing the reversed one. You should get the original list. Okay. Yeah, so actually you may want to ask that important question. Okay, if we have the sort, we are where you have the where you have this reverse option available. What's the use of this? So actually the issue here is I have used a kind of a misleading example. Okay, so because this is in actual numerical order. Okay, so when you reverse it, it comes in the reverse order. Okay, but yeah, so this is a bad example in that this is not actually sorting. Okay, in the reverse order, this is just reversing. So if you had for example computer science and engineering, if you did a sorting with reverse set to true, okay, reverse set to true, you would get the items in this order: and, science, engineering, computer. Okay, and if you want to go back to the original list, there is no way you can do it. Once you have sorted, there is no command called unsort. Okay, but here this is here if you had computer science and engineering, the reverse order would be the engineering first, and at the second one, science at the next one, and computer at the last one. So, and if you say reverse again, you will get the original list back. Okay, so so remember the very important difference between sort with reverse set to true and reverse method. Then we have this next built-in method called extend. So let's see how it behaves. It will take an iterable collection as an argument, which is basically a list, and it will keep on adding elements to the end. And so here, of course, the length increases as you keep on adding. Okay, right. So here is a sample code which shows this extend operation. Okay, right. We have looked at this example before also. So these are very important for the operation of for writing of programs which process data. Okay, I have this clear method, which is another built-in Python function. So if you have a list, okay, so this is very common. So you create a variable of the type list, and you do you populate that with various data elements, and you do various processing with that, and at some point you want to clear the list and repopulate it with new elements, so you can do some new task. Okay, so one way you can now clear out the list is to delete all the items one by one. Okay, oh, of course, as we have seen, we can delete by giving a range also. But when you want to write code that makes your intention very clear, we can use the clear method. Okay, so which essentially says no, make the list null. Okay, right. So here you can see how we call the method. So you can do the same by deleting. Okay, but the difference here is when you write programs, use of different type of functions will make your programming intention clear. Okay, so sometimes we want to delete items for a specific purpose. Sometimes we want to just empty out the list. So in such scenarios, using the clear method rather than deleting from the beginning to the end is the better option. Okay, so here's the running example. We have these other methods which are useful methods like count, which will give you the number of times an item appears in a list. So we call the count method, passing the particular value that we want to check. Okay, so let's say we have a list of student names. Okay, list of student names as attendance. Okay, so you are attending the interactive sessions over the semester. Okay, and suppose somebody gives me this whole list of attendees. Okay, it's a huge list of strings. I just want to know for a particular student how many times the student has attended, so I can just take the entire list. Okay, so for example, this would be a list with 1,000 students multiplied by 14,000 names. Okay, of course, not everybody is attending, so let's take 80% attendance, which is a usual number. So 80% of 14,000. So that would still be a huge list. So if I want to know how many times a particular student has attended the interactive sessions, I can simply call the method count on that particular list and pass the student's name as a string here, and it will return to me the number of times the student has attended. Okay, so like that, I'm just giving an example application. It's very convenient way to determine certain outcomes. Of course, if the student has not attended any of the interactive sessions, his or her name will not appear in the list, and I would get the result 0. Okay. This method copy is for us to create a copy of a list. Okay, so I'm specifically referring to a type of copy called a shallow copy. Okay, so there are, of course, you can figure out the other copies. One is shallow, the other one should be a deep one. Okay, so there are two types of copies. One is called shallow and other one is called deep. So a shallow copy means so you have a new copy. So any changes you do in the original list will not be affected there. Okay, so let me show that by this running example. So here's my original list with items 1, 2, 3, 4, 5. And I'm going to create a copy of that list and assign it to a variable called list2. Okay, so when I print list2, you can see I have the exact same values in the list. Okay, now I will append a new value to the list2, the copy. Okay, the value is 6, and now I am going to print the same 2 again. So when I print the original one, it is not affected. Okay, the copy is the one that got changed. Okay, so you can see when you create a copy of a list by calling the copy method, you get a brand new copy. So if you do any changes there, it will not affect the original of the original list. Here we have another built-in function in Python called index. So now this is similar to what we have seen here earlier, like count. So so like the count, where we went through the list to find items, okay, and see how many times it appears. Or we also had a similar method earlier. Let me get there. Like we can say remove. Okay, so remove would again, when we give a value, we'll go through the entire list and remove the item in the first instance it finds in the list. Okay, so now we have another function of similar nature, which is called index. Okay, where we will give a value and also a range. Okay, so in the earlier methods, we were not in a position to specify a sub range within a list to do its work. Okay, but here so if we want to do it that way, we will have to first splice the list and get that sub list out and do the operation. Okay, so here with the index method, we can search from an address start to an end, and check for a given value. And if the value is found, it will return us that index. Okay, so it is quite possible that you have multiple items within this range which match the value. What will be returned is the first one that that is present. Okay. So here's an example. Let's look at its execution. So the original list has this 1, 2, 1, 3, 4, 1, 5, 3, like that. So if I search for 1, so yeah, sorry. So this is, I'm searching through the entire list actually here. So you can do a sub list and check yourself. So I will get the, as the result, the first one. Okay. And if I am searching for 3, 3 appears twice. I will get the address location. Okay, so this is 0, 1, 2, 3. So the fourth element is at address location 3. So I'll get that one. If I search for 7, it is not in the list. So 7 is not in it. So I get a value error. Okay. So one way to actually prevent an error like that happening is to first check the count. Okay. So if you check for the count, and if the count is 0, you should not try to find the index. Okay. I would like to invite you to do the same by specifying the address locations. For example, if you give the address, starting address as 0, 1, 2, 3, starting address as 3, and 4, 5, 6, 7, say 8. So if you go from 3 to 8 and search for 1, you will get this index value returned to you. Okay, so check that to see how the method behaves. So it is very important that you try this out. For example, you might get a question in the final exam saying, here's a list. Here's the index method being called, and you will be shown 5 possible values as the output. Okay. And if you don't try out these commands yourself and familiarize yourself with this, you might get confused actually, okay, what the correct value is. So it is very important that you try out. So the value you get when you don't specify the range is different when you specify start and end range. Okay, so it is not it is the first occurrence in the given range. Okay, so here I have given the full range, so then you get the first occurrence. But if you are given a sub range like this, it will be the first occurrence from that sub range. So this I have given for completeness sake. As you already know, any list item we can access by its index operator. Okay, so it is called the index operator, the square bracket, and when we specify the different items at different indexes, we will be return either an individual element or maybe a composite element. Okay, so that you can see here. So I have the so let's look at this list, the second list, where I have elements within an integer, but 3 integer values initially, 1, 2, 3, and then I have a list at the 4th element, and then 2 other integer values, and within this one I have another list inside that list. So let's see what happens when we access them. So if I access element at address location 4, that would be 0, 1, sorry, yeah, at position 4, so I'm getting position 4. To get the position 4, I'm giving the address location 3. So 0, 1, 2, 3. So at the 4th position is this particular sub list. Okay, so that is what gets printed here as the output. Okay, so then within that one, within the list, within that item, I can, because it's a list by itself, I can access its second item. Okay, so the second item would be 0, 1, 2. That would be a list again. Okay, so I get 6 and 7, and within that one I can again access maybe the first element. So I have to be careful. So that I have to specify as the first element in the second element, in the original list's third element. Okay, so so it is given like this, but I have given the position as in this manner. Okay, so don't get confused. You don't write like this. This to just to show you that I have the original fourth element. Within that, I have the original third element, and within that, I have the second element. Okay, so it is to show the within context that I have put the brackets in this manner. But when you are accessing, you use the index operator repeatedly. Okay, in this manner. You can use the index operator with negative indexing also. Okay. So just as you would use 0 to access the first element, with -1, you can access the last element. Okay. And when you increase the negative value, progressively you come towards the beginning. Similar to when you start with 0 and increase the value, you progressively go towards the end. So that behavior is shown in this particular example. Right. So if you access -1, you should get 5, the last element. Okay. And if you access -5, you should get the first element. Okay. So counting from here, -1, 2, 3, 4, 5. So this is the -5. So be careful about this. Again, you should have a thorough knowledge of this indexing. And we have seen that students, if they haven't done significant amount of programming work by themselves, tend to make very simple mistakes. When we ask what is the item that gets printed, if you say print list within brackets -3, no? So so you would get confused in an exam like environment if you are not thorough with this indexing by writing code and testing. Another very useful way in which we use list is to do matrix operations. Okay, because nested list can be used to represent a matrix. Okay, and here I have you have three matrices shown here. Okay, so essentially what you have row-wise representation of matrices. Okay, and once you have a matrix defined in this manner, you can use nested loops to do matrix operations. Okay, so going from the range of values in a matrix. So this would be a 3 by 3 matrix. Each row is 3 values, and you have 3 such rows. So it's a 3 by 3 matrix, and you can do matrix operations like addition. So let's look at the actual code to see how it works. So so you can see I am adding matrix 1 and matrix 2 just to give you a quick idea how it works. So corresponding elements should get added. So 1 should get added to 1, and the result should be 2. 2 should get added to 2, and result should be 4. 3 should be 6. So you can see that has happened in the looped matrix operation. So this within this nested loop, we have done the matrix operation, and here's the correct output. Okay. So actually, when you print, it gets printed as a list of list. So 2, 4, 6, then 8, 10, 12, and then 14, 16. Like I have just used a smaller window, so it shows nicely like a matrix. Okay. So if you want to print like this, obviously, yeah, you will have to use your own pretty printing techniques. Okay. There are other specialized operators that we can use with list. For I'm going to discuss two such operators here: the addition operator and the multiplication operator. So addition will allow for concatenation. I think that is familiar to you from strings. So string concatenation is doable with addition. And here we have this repetition operation also. Okay, it's kind of a new operation that I want to introduce. So let's look at two lists, 1, 2, 3, 4. And we can create a new list L3 by simply adding these two lists. Okay, so a new list will get created here. Okay, new list, and the concatenation of the two lists will be the new list. Okay. Similarly, we can use the multiplication operator on a list, and a new list will get created. So let's look at the outcome. Okay. So here's the first list, and you can see I'm printing the memory locations also. So just look at on the last 5 digits. 12,192 is the memory address. 80,224 is the second list memory address. So I have created a new concatenated list. Okay, so 1 and 2. So the second list element will get inserted to the first list iteratively. So 1, 2, 3, and 4. So if you had list inside these lists, then they will get inserted as elements. And it goes into a new memory location, 80,480. Okay. And I have used the multiplication operator for creating a repeated list. So I'm doing it for the first one. So now the elements in the list, so there are 2 elements here, they will get repeated the number of times you ask that to be repeated. So here it is 2. So I have first iteration, and then I have the second iteration. So this is a concatenation by just iterating the number of times you have asked that to be copied. Okay. So these are easy ways in which you can create new lists depending on the application you want to write. So I want to compare between lists and strings and see how they behave. So when you take a list and pass, sorry, when you take the list method, okay, when you take the list method and pass an iterable value to that, okay, it will create a list by iterating over the iterable collection. So a string is an iterable collection. A string is a iterable collection of characters. Okay, A, B, C, D, E. These are individual characters. You can iterate one by one. So when you use the list method or the function, it will iterate through this collection one by one and fill that into a list. So you get a list like that. Whereas if you use the string method, okay, string method, it will not separate out the elements like that. So if you give iterable collection to that, it will create the same thing in this case. Okay. So what would happen if you pass a list to a string? So what I do here is I take a list, sorry, I take an iterable collection here, the string, and pass it onto the list method, which will now return a list to me, and then I pass that list to the string method. Okay. So here what happens is the each of these individual elements in the string becomes a string by itself. Okay. Right. So what gets output finally is the same thing you have here. Okay. So the list that was created remains. And we have a couple of other functions. If you have as a list of numbers, you can take its sum by simply calling the sum method, passing on that iterable list and telling where to start. Okay. So if I want the whole list, I can leave the second argument blank. But if I want to start from somewhere else, I'll just give that particular address location to start, and it will count the values from there. Okay. So this is very useful if you want to take a sum of a set of values or compute an average. So for example, to compute the average, what I will do is I will sum the numbers and divide it by the count, which I can just take by taking the length of the list. Yeah, so I have a sample here. Mind you, I have the real division here because I'm computing the average value. So the printed value is a floating point value. More functions available with the list. So if you have a iterable collection, which is a list, and if it has elements that are that have order, then you can find the maximum value or the minimum value. So this is especially useful for numerical values and values which are in a particular alphabet, okay, like strings. So so I have a running example here, one for numbers and one for strings. Okay, let's see how it behaves. So my list is 1 to 10, so I can ask for the minimum value in the numbers list or the maximum number in the numbers list, and I will be given the correct values. And then I have a list of strings. So this is actually code for A, B, C, D, E. And the minimum value would be here A, alpha, and the maximum value would be E, here echo. Okay, right. So yeah, remember, if you are asking for minimum or maximum, it must be values which have some natural order, okay, like numerals or strings or characters. Then we have these two functions, any and all. They return Boolean values. Let's see how they perform. So the any, the function any is the equivalence of O. Okay. So as you know, if we have a Boolean statement. Okay, A, O, B, O, C, O, D, O, like that. If the variables are separated by the O operator, our result will be true if at least one of these variables have the value true. That is how the O operator behaves. And if all of them are false, only we will get the value false. And similar to that, if we have a logical expression A and B and C and D and like that, the final value will be true only if all the values are true. If even one value is false, then the result is false. So this particular behavior we can apply to a list using any for O and all for N. Okay. So let me give the quick example here. So if you look at 3, 6, 9, 12, and 15, all these values are divisible by 3. Okay. But they are not all of them are divisible by 2. Okay. So so let's look at a running example. Okay. So what I do is I have this first list of values to the second list. Okay, the second list I add values if values in the first list are divisible by 2. So I do an integer division, and if the remainder is 0, that means it is divisible. Okay. So I have, so I'm going from range 0 to 5. Then what I do here is I print on the screen this list. I check whether all of these values are divisible by 2, right? So the values, okay, so this is the list. Okay. So if you check, not all the values are divisible, because no, the these values like 15 and 3 and 9, they are not divisible by 2. Okay. And if I has any, I will, so so all is the AND function, any is the O function. So it has elements that are divisible by 2. So yeah, so this is just an example of using any or all. But the idea here is the operator or this particular function behaves in that manner of a logical or a logical AND. Okay. So it could be quite useful in certain applications where you want to see whether a particular set of particular list of data items have a common attribute. Let's look at this this method, which is the filter. Okay. So filter is to essentially test a list against a particular property. Okay. So that particular property we pass as a function, and then we pass an iterable. So so I'm using this term iterable all the time, because list is only one type of iterable. So you can pass any other type of iterable data structure also. But of course, in this our discussion for this part of the lecture, the data structure we are focus is the list. So what we'll pass is a list. So what happens in the filter method is the function will be applied to each of these elements in the list. Okay, right. So I have an example here. So let's say we have a large text, right? Say a Wikipedia page or like that, or a government document, and we want to so sometimes when we release, so you have seen, for example, recently some documents have been released disclosing certain information by the International Committee of Investigative Journalists. So they are only releasing the information. So previously they have released the original documents also, and when you release such documents, if there are some personally identifiable information, this is a very important area in computer science. So when you disclose information to the public, you have to be careful not to disclose personally identifiable information unless you have approval for that. So removing certain certain text is called redaction. So this redaction is essentially saying remove these particular strings. Okay. So here I have an example of how to do this efficiently using Python. Okay. So I have defined a function here called redact. Okay. So in this function, I have two words, Mary and melon. Okay, it could be anything. Okay, you can have Sri Lanka. Okay, and if I give a variable, if when I pass a variable, that would be a list. Okay, in that if that list contain these words, sorry, yeah, if I'll pass strings. So if the string that I pass is present in this particular list, I will return true. Otherwise, I'll return false. Okay. So then I have a very lengthy list. Actually, this one goes on. So in the next slide, I'll show it to you. So what I do is I will now use the filter method, pass a function as the first argument, that is this redact function. So this one I'm passing as the first argument, and then this very large text I am passing that as the second argument, and I will get a filtered list as the output. Okay. So let me show you the run time of that. So you should once you download the slides, you can zoom on the slide to read it carefully. So you can see I have the function here, right? I have the function here. Then I have a text here. Okay. So this is now right now we have a pandemic. So this is about a pandemic that happened in 1906. So 115 years ago. At that time, the patient zero, the name was used to actually name the particular pandemic. Okay, so so this is that text. Okay, so what I'm doing here is I'm going to pass this particular text and this redacting function to the filter method, and the filter method will return to me a list of strings. Okay, so essentially every time it encounters the list, a word that I want to redact, it will return true. So you can, I hope you can see this code here. So the first, in line number 13 and 14, I simply print the whole text, the original text. Okay. In line number 16 and 17, what I do is I get the filtered list and print it. So you can see in the filtered list, I have all the text that match these two words. Okay. So if I am given some text, and if I want to filter out some text, I can find out the presence of those text in the original text by using this kind of a function. Okay. Then this particular method enumerate allows me to create an enumeration. So let's see how this behaves. The first the first argument is an iterable, which means a list in our case, because we are using the list as a iterable, and we can specify the starting position. Here's my example text on how it behaves. Let me show you the runtime. Okay. So this is the original text, and now I'm saying enumerate. So I can give the starting value to enumerate. So essentially, this is giving an address or an index to the content in the list. So I can start with -8, for example. So the first item will be -8. Second item will be -7, and it will keep on increasing. Okay. Right. Now you can see I am passing the input list, the text, and the starting location address -8 to the enumerate method, and I get the enumerated list. So when I print, this is what gets printed. So this is called a tuple. We'll discuss this later. It's a tuple. It's the pair of values, the index value and the content. Okay. So index value. So this is the index. This is the content. So you might ask, what is the use of this kind of method? So for example, now, if I have a name list, okay, so I have the names of the students, 1,000 names as a list, okay, well, not necessarily 1,000, okay, some large number like that, so if I want to assign a number to each of these names and print it out, I can use this enumerate, okay, and the advantage is I can decide the starting value. For example, I might start at the number 100, and then I have the students numbered from that, or numbered from 1,000 or whatever. So I can decide on the starting value, and then I can print a list with this number and the name, okay, right? So there are many such useful applications of this type of method, okay, and all of these methods that I'm explaining, like these extended methods, you can achieve the same thing by writing your own function, okay. and using the basic list functions like length and splicing and using an iterative loop. But the difference between writing your own method and using the built-in functions is Python built-in functions tend to be much faster than what your functions would achieve at runtime. So that is the advantage. Right. So this brings to an end our discussion on the list. So I have given a simple example exercise for you to try out to do a inversion of a 5 by 5 matrix of integer values. If you do that, you will get a pretty good idea about matrix representation through list and loop operations. Okay, and as I have noted here, you must try out the sample code with different values to get a better understanding. Okay, that's the end of our discussion on the list. Next, we will move on to tuples and sets.